Hello students, welcome back to my channel Concept Tech 2018. I am Dr. Sunanda Manke and this video is a part of series on online electronics laboratory, and in this part we'll discuss the lab exercises on analog to digital and digital to analog converter circuits. This is the list of experiments which will be performed in this part. We have one experiment on analog to digital conversion using flash converter. Then two experiments are on digital to analog conversion, weighted binary method and R2R ladder network method. The last experiment is on binary code conversion and it will be performed in virtual lab. This is the experimental setup which will be used to perform a to D and D to A conversion experiments. This is the trainer kit, and outer one is the general purpose kit on which this trainer kit is mounted. The DC supply to this trainer kit is provided by these knobs given here. Then we have input switches here. Digital input is given through these switches, and you can observe here these switches are having two positions, high and low. So we can change the position of the switches and accordingly we can apply 0 or 1 input to the D2A converter circuit. So digital input is provided using these switches. Then we have this variable analog input knob. With the help of this knob, analog input can be varied and it can be connected using these 2 points here. And this is the voltmeter which is used to display the voltage, analog voltage here. So when we are converting analog signal to digital signal, the input is given by this knob and the output is observed on the LEDs which are available here, or even they are available in the kit as well. And when we are doing the experiment on digital to analog conversion, the digital input will be given through these switches and analog output is measured on this meter. Although this acts as both voltmeter and ammeter, but we are going to use it as a voltmeter. This is the trainer kit on which experiments will be performed. You can observe here we have a flash A to D converter, 3-bit converter here. Then we have this weighted binary D2A converter here and R2R D2A converter is here. So these three experiments will be performed using this trainer kit. Now this is the first experiment, A to D flash converter circuit. So A to D flash converter basically converts analog signal to digital signal, and this gives the flash converter IC 74148 IC here. The analog input, variable analog input is connected to this pin ADC input 0 to 5 volts. We are going to connect analog input here and input voltage is varied and digital output is observed on these LEDs which are present here. In flash converter we have comparator circuits and comparator outputs are converted to digital output using this IC. The flash converter is the converter which is having highest speed among all the analog to digital conversion circuits available. So let's do this experiment. Let's do the experiment on A to D flash converter circuit. You can observe here these two are the inputs which are connected to the variable analog input which can be varied from 0 to 15 volts. We just need to vary it from 0 to 5 volts. And the output is observed on the LEDs here which will give output in the digital form. So we'll start varying the input. You can observe 0, 0, 1. The uppermost is LSB. 0, 1, 0. 0, 1, 1. 1, 0, 0. We are increasing the input. 1, 0, 1. 1, 1, 0 and 1, 1, 1. That is the highest possible input value which can be converted to the digital output, right? We can do it again. Now we'll reduce the value and we'll observe the digital. You can see here I am reducing it 1, 1, 1, 1, 1, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 0 and 0, 0, 0, right? We can do it one more time. I'll increase it. You can see the knob. This is the knob from where analog input is increased. 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. You can observe 1, 0, 1, 1, 1, 0 and 1, 1, 1. This is the maximum value of the analog input which is converted. I am reducing it now and you can observe the same pattern for reduction also, right? This is how this flash converter works. In the experiment, the analog input is varied from 0 volts to 3.5 volts, and LEDs follow the binary sequence which is given in this table. So you can observe here input voltage is varied from 0.0 to 3.5 volts, and corresponding to the input given, the LEDs switch on and off and represent the binary number. So when 0.0 is applied, all the LEDs are off, representing 0, 0, 0. And when the highest voltage, that is 3.5 volts, is applied, all the LEDs are on, representing 1, 1, 1. So as the input voltage is increased, the binary sequence changes or increases in the given pattern. It's a 3-bit converter, so we get maximum 111 value at the output for the input voltage 3.5 volts. I hope you have understood how this flash converter circuit works. Thank you.